This clip is for viewers who are interested in Microsoft's cloud document database, Azure Cosmos DB. When the team started working on the proof of concept for this provider, many of us asked, why would you need an ORM, an object relational mapper, to work with a database that isn't even relational? The reason is because a lot of people were asking for it. They were familiar with using EF Core and using Azure Cosmos DB and didn't want to have to learn a whole new set of APIs to interact with this database. Cosmos DB directly exposes a number of APIs for developers to communicate with it, and one of those is SQL. When you use SQL to interact with Cosmos, the Cosmos DB data is represented as JSON documents in a document database. So EF Core's Cosmos provider takes advantage of its ability to build SQL while using the Cosmos DB flavor of SQL to talk to the database. The data is stored as JSON documents, but the provider knows how to handle that as well. With EF Core, you can do a lot of the basic tasks, inserting, updating, and deleting data, and reading data. And you can do so using EF Core the same way you use it for any other database. You only need to pass in the connection info to the Use Cosmos Options Builder method. And there are plenty of attributes you can tweak to affect how EF Core interacts with that database. As long as you have an existing Cosmos DB account, EF Core can even create databases, containers, and partitions as needed, just as EF Core can create databases and tables in SQL Server. I think the most important thing to keep in mind, however, is that there is a lot to understand about designing your models for persistence in document databases, especially when using them for their target purpose, which is working with large amounts of data. EF Core is only a means to make interaction easier, but it's important that you're familiar with the difference between relational databases and document databases before taking advantage of it. Here's a quick look at the console app from earlier modules. The data project now uses the Cosmos NuGet package instead of SQL Server. And rather than a single connection string, as you would use for the parameter of Use SQL Server, the Use Cosmos method expects the URI of your Cosmos account, that account's access key, and the name of the database. But you should definitely use standard practices for securing your endpoint and key. This kind of database doesn't generate primary keys like SQL Server does. So the key and foreign key properties in my classes are now GUIDs, and I'm making sure that whenever I instantiate a new class, it creates its own GUID key. And if you're querying data, then whatever GUID is coming out of the database will override that value that was created in the constructor. But my EF Core related code is just the same as before. The provider will do the hard work of transforming queries and commands into the correct SQL syntax and materializing the returned JSON documents into my objects. Here's the JSON document in Cosmos DB that was created by my method. The document is for an author. There's the new GUID generated by my code, but notice there's another ID, which is a combination of the type and the GUID key. That's created under the covers by EF Core because it's possible to have documents of different types that have the same key values. And yes, with GUIDs, that chance is very, very slim, but you could be using integers or strings or some other way of creating keys. And below all of this, there are a bunch of underscore properties. All of those are created by Cosmos DB. They're not properties of my classes or part of my data model. Also, notice that the related books are embedded within the author document. That's because of how I modeled my data. There are other ways to set this up where the books would be stored in separate documents. You can learn more about this provider from the docs, as well as some great content created by Jeremy Lickness, who's the program manager for all .NET data access at Microsoft. And he, too, loves this provider and loves working with Cosmos DB. I'll provide links at the end of this module for those. I mentioned earlier that EF Core supports transactions inherently, and I want to be sure you have a little more insight into this support. By default, EF Core will use database transactions whenever you call save changes. You can expose those in the logs, but here's a quick look in SQL Profiler. A transaction is started before the first command is sent, and then a commit after the last command has completed. If any single operation fails on the database, every one of the commands that's already been performed will be rolled back. The database will return its error to EF Core, and EF Core will return the relevant exception with whatever details were sent from the database. There's a lot you can do to control how the transactions work. You can create your own database transaction and force EF Core to use that within its scope. Or you can tap into the transaction that EF Core is creating and manipulate that. You can even override the database transaction completely with a system transaction, which would combine the database interaction with other logic to determine if everything within there should be committed or rolled back. I'll show you one of these capabilities in action, which is to control the transaction created by the context. I've added a method into my solution to make sure that if the publisher cancels a book, which in our system means the book will get deleted, that before all of those cascade deletes also removes any knowledge of any artist that was assigned to that book's cover, we can make a note in the artist's new notes field about this. The first iteration of this method does two things. First, it finds the artists that are tied to that book as designers of its cover, and then updates their notes field with a note about this book being canceled. Then I use the easy way of deleting the book. Instead of retrieving it from the database and deleting it using EF Core, I'm just executing a raw database command, although it is interpolated, so it will be parameterized. After that, assuming all goes well with the delete and the cascade delete, I'll know it's safe to go ahead and save the changes to the author's notes. When I run this, notice in the profiler that the delete method gets executed as expected when I call it. But there's no transaction around that because it's a single command, so nothing would need to get rolled back. Then when I call save changes, EF Core starts a transaction, updates the relevant artist, only one in this case, and then commits the transaction. But what if something fails with the delete command, or one of the update methods fails? All of this logic goes together. I don't want to update the authors if the book is still there, or delete the book without having fixed up the author notes. I really want them to be in a single transaction. So this is where I can take advantage of one of the ways of customizing the transaction handling. Here's a new version of that method where I've wrapped all of the logic from the first method inside of a transaction begin and a transaction commit. So at the beginning of the method, I trigger the context to start a new transaction in the database, and I'm capturing that transaction in a variable. Then in a try-catch statement, I execute all of the same logic as before, running the query to get the authors, applying the changes to their notes, calling the raw SQL delete method, and then save changes. When all of that is said and done, and there's been no exceptions thrown, then I will hit this last line of code, transaction commit. When I run this version of the method, notice the details in the profiler this time. Everything is inside the transaction. My queries, my raw SQL delete, and the updates sent by save changes. Those transaction save points are something you can read about in the EF Core docs. And around all of that is the begin transaction and the commit. If I never reach that line of code to commit the transaction because an exception was thrown somewhere within this try block, then EF Core would have sent a rollback, triggering the delete and the updates to the author all to get rolled back together, as they should. A common type of exception is a concurrency exception. EF Core supports optimistic concurrency and allows you to include row version properties in your entities. If the database sees that you're attempting to update data that was updated by some other user or process since you retrieved it, it will throw a DB update concurrency exception and roll back the entire transaction. Working with row versioning and handling transactions and errors are pretty advanced topics, so I'll stop at this point where you now have an awareness that this functionality exists, and you can learn more about it when you're ready. Before wrapping up this module, I wanted to answer a few frequently asked questions about EF Core and database connections, with the goal of ensuring that you're aware of these capabilities of EF Core. The first FAQ is about dynamic connection strings, Although my console demos simply hard-coded the connection string into the DB context, you might have noticed the many times I pointed out that this was helpful for getting you started with your EF Core education, but definitely not a recommended practice. In the ASP.NET Core module, you saw how the connection string was stored in appsettings.json, and I was able to read that when setting up the service to instantiate pub context. Storing connection strings in files that aren't compiled into your code is a common way of dynamically introducing connection strings. You can modify or replace those text files without having to recompile or redeploy your application. And in fact, when we told ASP.NET Core to look for the connection string, appsettings.json is only one of the places that it looks for configuration information. Another place is in your computer's environment variables. And there are other places it searches as well. So there's lots of ways to store and read those connection strings. What about other ways to use them? EF Core has a feature called interceptors, which allows you to tap into EF Core's pipeline, and one of the things that you can do in there is make modifications to an outgoing command. This is a pattern you could take advantage of to inject a connection string. The ability to avoid hard-coding your connection string is especially important when you need to include credentials, and there are quite a few ways to store the string or just the credentials and read it as needed in your code. Felipe Gavilan has an interesting blog post that demonstrates a number of examples. And if you're using a service like AWS or Azure, they also provide a number of ways to store and retrieve secrets. Here's another FAQ. What about reusing connections and connection pooling, or even DB contexts? To answer the first question, database connection pooling is controlled by the database provider. However, there is another kind of pooling in EF Core, which is DB context pooling, allowing EF Core to reuse instances of a DB context rather than instantiate new ones each time. Instantiating a DB context isn't actually that resource intensive, but when it comes to web applications, especially highly transactional ones, there are definitely times when you can gain performance improvements by pooling those DB contexts. It's easy enough to switch from the standard way of instantiating a context to using pooled ones. Instead of using the service's addDBContext, you would use the addDBContext pool method. And then whenever an instance is needed, EF Core will check the pool before creating a new one. There is some additional benefit with DB context pooling that helps with database connection pooling and pooling other database resources. So that comes for free along with a pooled DB context. You can learn more about this from the EF Core docs at bit.ly/poolingdocs. The last FAQ I want to address is what happens if the connection to my database gets dropped when I'm in the middle of executing a command. EF Core has a feature called connection resiliency. It's not on by default, but you can easily configure your provider with the enable retry on failure method, just like we've done with use SQL Server and other configuration methods. What this does is reads the code that the database returns indicating the reason for the failed connection, and that's from a list of known codes. And depending on the code, it will retry the command some predetermined number of times. While this feature does have its default behavior, it's also possible to tune it to your own needs. I've created a shortcut to the documentation at bit.ly/EFC resiliency doc.